Hello all. As we have seen from the previous classes that the passive elements are classified into three categories. First one is resistors, second one is inductors, and third one is capacitors. In the last video, we have discussed about the resistors along with the Ohm's law. So combinedly, we have seen about these Ohm's law and resistors. Now in today's class, we'll see about inductors and capacitors. Remember, a resistor is the energy dissipating element, but whereas inductors and capacitors, these two are energy storing devices. So they can be act as virtual sources. Actually, they are not sources, but they can be act as virtual sources. So resistor is just energy dissipating element, whereas inductors and capacitors are energy storing devices, right? So we'll see first we'll see inductors and then later we'll see the capacitors. Right. What is inductor? Generally, we know conductor take a finite length of the conductor and twist the conductor like this. If it is the conductor like this, a finite length of conductor is twisted like this, which means in the form of a coil, then this will be an inductor. Okay, so this is also one of the basic circuit component, and this inductor will stores the energy, and it will be represented by the letter L. Okay, and the units for the inductors are henries. Simply, you can use H. Okay. What about the property of the inductor? Generally, what inductor will do is inductor opposes the sudden changes in the current. Remember, inductor opposes the sudden changes in the current. So the current in the inductor will change slowly, not rapidly. Generally, let us take the waveform. Let us consider this waveform. This is a current waveform. Suppose it is like this. You can see from this point to this point, the current is suddenly raised. And whereas from this point to this point, the current suddenly dropped. If we apply this kind of current to an inductor, then what will happen is inductor does not allow this sudden change. What it will do? So the current in the inductor will start rising linearly like this, and it will drop linearly like this. So it will go linearly and it will come down linearly, and there must be no sudden changes in the current. So this is the property of the inductor. So inductor does not allow any sudden changes in the current, right? Of course, inductor will be represented by the letter L. Units are henries, simply H. So as we know, we already derived the voltage drop across the resistor in the previous video, which is V is equal to I into R, right? So this is the voltage drop across the resistor. This came from Ohm's law. Okay. Similarly, for an inductor also, we can get the voltage drop across the resistor. So for the convenience sake, I'm writing the letter V suffix R, and this is the current I suffix R. So this is across the resistor. Similarly, using the same Ohm's law, we can also write the voltage drop across this inductor, which can be written as V suffix L, which means voltage drop across the inductor can be written as V suffix L is equal to L into di by, so di by dt. See how this d by dt came? This is due to the property of the inductor. What is the property of the inductor? Inductor does not allow the sudden changes in current, right? So it does not allow sudden changes in current. So the current will change slowly based on the time. So d by dt indicates the change in time with respect to the change in current. Actually, this d by dt is having two terms. Di by dt having two terms. First term is di. Di means small change in current. Similarly, dt is a small change in time. So from the property of the inductor, we can write this equation, and where L is the inductor value. So this is also from the Ohm's law. Okay, so from this equation we can calculate, or we can write the inductor value L is equal to voltage across the inductor by the current which is passing through the inductor, that is di by dt. So this is how we can write the inductor value. However, you can see This equation is completely in terms of voltage and current, which means in electrical parameters. But we are also interested to write the inductor equation in terms of physical parameters also, because for the resistor we have written using the physical parameters also, because both electrical and physical, both the formulas have been written there. So R is equal to rho L by A. This is for inductor, where rho is the resistivity, L is the length of the wire, and A is the area of cross section. This is the physical based formula, physical properties based formula, or physical parameter based formula, we can say. In the same way, for the inductor also, we can write for inductor based on the physical parameters, we can write L is equal to mu A n square, mu A n square by L, where mu is the permeability, A is the area of cross section, and is the number of turns, which means, see here, this look like a coil, right? So number of turns in the coil. N means number of turns in the coil, and L is length of the coil or length of the wire. We are considering a unit, I mean a finite length of the wire, right? So L will be the length of the wire, A will be the area of the cross section, and N is the number of turns. So how many turns we are twisting the wire into a coil, that will be M. And what about this mu? Mu is permeability. Permeability. So this permeability can be based on two parameters, mu naught and mu r. Mu naught and mu r. Mu naught into mu r simply is nothing but mu. What is mu naught? Mu naught is the constant value, which is 4 pi into 10 power minus 7 Fermi per meter. And mu r will be the relative permeability. So this relative permeability is depends on the material or the medium. On which medium we are placing this inductor, at which medium we are using this inductor. Based on the medium, suppose if we keep that inductor in our living area or in our living space, then the medium will be air, no? So based on that medium, mu r value will be decided. So mu r value will be varied based on the material, whereas mu naught value is constant. This is a constant value, 4.2 10 power minus 7. So mu naught into mu r will become the total permeability, mu. So this is how mu can be calculated, and A is area and is number of turns, L is the length. So using the physical parameters, we can estimate the inductor value like this. Now we know what is inductor, how inductor will be formed, and what is the property of the inductor. It does not allow sudden changes in the current, right? And how can we calculate the inductor using Ohm's law? This is the formula. This may be, you can write, this is equation 1. Similarly, using the physical parameters, so this will be equation 2. So using these two equations, we may get, or we may calculate the value of inductance. Okay. And at starting of the video, I have told you this inductor is actually an energy storing device. Inductor and capacitor, both are energy storing devices, right? So this inductor stores the energy in the form of magnetic field. It will act like a magnet when we give electrical energy. That means if we apply electrical energy to this inductor will get charged by the electrical energy, and that charge will be stored in this inductor in the form of magnetic field. So that's why this inductor is also called as electromagnet, which means by means of the electricity, the inductor is acting as a magnet. So that's why this inductor is also called as electromagnet. That's why this energy is also called as electromagnetic energy. Simply magnetic energy, but technically speaking, it will be electromagnetic energy. That means the electrical energy is converted into magnetic energy, and that will be stored in the inductor. For the some part of time, inductor stores the energy. I mean, it will charges and it will stores the energy. Whenever we require, we can extract that energy from the inductor in the form of magnetic field. To calculate the energy equation, we already know the power formula and energy formula. So using those formulas, we can get the energy stored in the inductor will be half into L into I square. Half into L into I square. L means the value of the inductance. I means the current which is flowing through the inductor. Okay, so this is how we can calculate the energy that can be stored in the inductor based on its value and the current flowing through the inductor. So this is about inductor. Now we will go to the next one, next slide, capacitor. Right. You see, in the same way, like inductor and resistor, the same way we can also discuss about the capacitor. See, the capacitor can be formed basically by taking two charged plates which are arranged parallelly, and these two charged plates are separated by an insulating medium. So these two charged plates will be separated in between by an insulating medium. You know what is insulator? So by an insulating medium, then this arrangement will be formed as capacitor, and this will be the symbol of the capacitor. So the capacitance will be indicated by the letter C. So this capacitor also one of the energy storing element. Okay, so the charge on these two plates will be different. One plate it will be charged plus, one plate it will be charged as minus. Okay, so plus and minus. So when we apply electrical energy to this capacitor, if we apply electrical energy to this electrical energy will be stored in the capacitor in the form of electrostatic field, I mean electrostatic form. Simply, it will stores the energy in the form of electricity, like virtual electricity, like battery. Battery is the one of the best example. Uh, I mean, which can be very similar to the capacitor, because whenever we require the electrical energy, we can extract it from the battery. In the same way, if we require electrical energy, capacitors will be delivering that energy whenever we require in the form of electric field. So that's why the energy stored in the capacitor will be in the form of electrostatic energy, right? And the units for this capacitor is farad. Simply, we can represent it by the letter F. So F will be used to represent. And coming to the calculation of capacitance, generally the capacitance will be calculated in electrical way as well as in the physical way, as we have did for resistor and inductor. In the similar way, we can calculate the uh, capacitance value in these two ways. Using Ohm's law again, we can write the current flowing through the capacitor I suffix C is equal to C into, which means C means the value of the capacitor, dV by or dV suffix C. Why I'm keeping suffix C for all the components current and voltage means that represents the capacitance. So this is across the capacitor. So according to Ohm's law again, we can write IC is equal to C into dV by dt. See here we have written the equation for current. Previously we have written the equations for voltage. V suffix R for the resistor voltage, V is equal to I into R. Similarly for the inductor also we have written V is equal to L into di by dt. But for the capacitor, we are writing this Ohm's law in the form of current. So I is equal to C into dV by dt. If you want, you can also write for voltage also. Voltage can be written like this. Voltage equation can be written like this. V suffix C, voltage across the capacitor. From this equation, we can write apply integration on both sides to cancel out this differentiation, because we want this VC, right? To get this VC, apply integration on both sides. Then bring this C this side. So C will become 1 by C. And if we apply integration here, it will be integral I suffix C dt. So this is how the voltage of a capacitor can be written using Ohm's law. So in the similar way, if you want to write the capacitance value, or if you want to calculate the capacitance value using the physical parameters, you can also get it by using this formula. Capacitance C is equal to epsilon into A by D. What is this epsilon? Epsilon is the permittivity. Epsilon is equal to epsilon naught into epsilon R. Same we have seen in the inductor, but there we use mu. Mu is nothing but permeability, but here epsilon is permittivity. Epsilon naught is a constant value, whereas this epsilon R is variable based on the insulating material. What insulating material we are using, based on that material, this epsilon R will be changed, whereas this epsilon naught is constant, and this constant value will be 8.845 into 10 power minus 12. So this is constant for all the parameters, whereas epsilon R will be changed based on the insulating material what we are using. So this is about epsilon. And what is this here? A is area again, area of the capacitor. or area occupied by this capacitor, and d is distance between these two plates. So using this formula, we can also get the capacitor value, and all these parameters are physical parameters. So this is how we can get the value of capacitor, as we did for inductor and resistor. In the same way we can get. And what this capacitor will do, generally a resistor means it will opposes the flow of electrons. Inductor means inductor does not allow sudden changes in the current. But what capacitor will do? Capacitor does not allow sudden changes in the voltage. This is the property of the capacitor. It does not allow sudden changes in the voltage. That's why we have written this formula dV by dt. So the voltage, small change in the voltage can be done with the small change in time. This represents does not allow sudden changes in the voltage. So this is for the capacitor. And capacitor is also an energy storing element, and the energy will be stored in the form of electrostatic energy. That stored energy can be calculated using this formula, which is half into CV square, where C is the value of the capacitor, V is the voltage drop or voltage across the capacitor. For inductor, we have seen that as half Li square, but here it is half CV square, right? Thank you.